Hello, Algebra 2 students. This is Mrs. Herbert, and in this lesson, we're going to be putting together a few concepts. Now that we've aced factoring, we want to be able to factor a polynomial function in order to solve for its zeros, and then use the zeros along with the end behavior to sketch a graph. Let's review our steps to factoring. We always begin by finding the GCF. Then we can use head times but, adds to get the gut. But remember, this only works for trinomials. So if we're working with 4 terms, then we move right into factoring by grouping. And then, of course, our final step is to check our answers. In our first example, let's graph f of x equals negative 2x to the third minus 5x squared plus 12x. In step 1, we look for the GCF. In this case, it's negative x. Notice that we're including the negative as part of the GCF because the leading coefficient is negative 2. When we factor out negative x, that leaves behind this trinomial, 2x squared minus 5x minus 12. So we take that GCF of negative x and we just bring it down to the very bottom. We're going to include it later as a part of our factored form. Then we focus on factoring the trinomial inside the parentheses. So we use head times but, 2 times negative 12, and that gives us negative 24. Adds to get the gut. So from our list of factors of negative 24, we're searching for 2 factors that will give us a sum of negative 5. From our list, that's 3 and negative 8. So we're going to use 3 and negative 8 to split the middle term, negative 5x. So we rewrite the trinomial as 2x squared plus 3x minus 8x minus 12. Next, we factor by grouping. So we create our 2 groups and then factor out the greatest common factor from each group. From the first group, we can pull out an x from each term. That leaves behind 2x plus 3. From the second group, the GCF is negative 4. Notice that also leaves behind 2x plus 3. Then we bring down the factor that's in front of each set of parentheses, x minus 4. And our third factor is the common set of parentheses, 2x plus 3. Our final step is to check our answers, and we can do that by multiplying everything out. Now that we've found our factors, we want to use our factors to solve for the zeros. Here are those factors again. To solve for the zeros, we're looking for the values of x that would make the function equal 0. So we're going to take each factor one at a time and set it equal to 0. So negative x equaling 0 means x equals 0. If x minus 4 equals 0, it means x is equal to 4. 2x plus 3 equals 0 means x is equal to negative 3 halves. So we have 1, 2, 3 zeros. Next, we'll put all of them on a graph. Now that we have the zeros plotted, we want to determine the end behavior of the graph. And there are a couple ways that we can do this. One, we can just look above and see that we solve for 3 zeros. That means that the degree is 3. We can also look at our factored form and see that the leading coefficient in front of that x was something negative. Or we can just go back to our original polynomial and see that the leading coefficient was negative 2 and that the degree was 3. So we know we're working with an odd degree and a negative leading coefficient. This means that on our graph, the right end will go down while the left end goes up. And then all that's left to do is just fill in the missing part of the graph. Let's do one more together. In example 2, let's graph f of x equals x to the third minus 2x squared minus 4x plus 8. Let's search for GCF. In this case, there's nothing that will factor out of all 4 terms. Also, notice that we're working with 4 terms. This is not a trinomial. So we're going to move right into factoring by grouping. So we'll create our 2 groups, and then we'll factor out the greatest common factor from each group. From the first group, we can factor out an x squared. That leaves x minus 2. From the second group, we will factor out a negative 4. That also leaves x minus 2. We'll bring down the 2 terms that are in front, x squared minus 4, that creates our first factor, and then bring down the common parentheses, x minus 2. Now, we're not quite done factoring yet, because when I look at x squared minus 4, I notice that that's the difference of squares. So I'm going to take this one step further and factor using my rule for difference of squares. X squared minus 4 will factor into x plus 2 times x minus 2. And then we can't forget that x minus 2 from the line above. So this is our final factored form, and we can condense it. Since we have x minus 2 repeated, I'm just going to simplify that as x minus 2 squared. Finally, check your answers. Next, we want to solve for the zeros. Here's our factored form. Let's take the first factor, x plus 2, and set it equal to 0. Solving gives us x equals negative 2. When we set x minus 2 equal to 0, we get x equals positive 2. So we have 2 zeros, or so it seems. Remember that x minus 2 was squared, which means that 2 is a double root. So technically, we have 3 zeros. So we'll take our zeros and we'll put them on the graph. And then the next thing we need to do is consider what the end behavior looks like. So we know we've got 3 zeros. It looks like the leading coefficient is positive 1. There's nothing in front of that first factor of x plus 2 in factored form. Or we can always go back and look at the original polynomial function. We see that it's a degree 3 and that the leading coefficient is a positive 1. So with an odd degree and a positive leading coefficient, we know that the right end of this graph goes up while the left end goes down. And all that's left to do is fill in the missing part of the graph. This concludes your lesson, and I hope that you will take the time to ask your teacher, reach out via email, or if you're in person with your teacher today, ask questions if you need help on today's assignment.